All right, and since we did this kind of representation using letters or using numbers, so how it is possible to Java to convert a number to a letter? So from a decimal number to a letter, it looks really like a int, but it is here to represent a character. So based on that, we can understand about the typecasting. And therefore, is free space inside a nested door. So the larger the nested door, the more space there is. So like this, the nested door, which you can put each door inside of the bigger ones. So in the same way is the idea of the typecasting in Java. So byte, it is the smallest type for int numbers. So everything that you can put in a byte, you can also put in a short. Short, it is bigger than a byte, so there is some information, some data that you can represent as short, but you cannot put inside of a byte. Okay, so right here, it's an schema of the allowed type conversions. So you can convert from byte to short, from short to int, from int to long. From char, you can convert also to int. From int, you can convert not just for long, but you can also convert to float and double. And to float, you can also convert from long. So from long, you can go also to float and double. And the only way you can go from float is to double. And from double, there is no assurance that you can convert to any other of these kinds, since double it is the biggest type. Okay, so solid lines indicate conversion without the loss of information. Conversions that may involve information loss are indicated using the dashed line. So please pay really attention about these kind of conversions. So from whole numbers to the floating numbers, floating point numbers, int to float, or the long to float or double. It can involve information loss. Okay, so there is no assurance on these conversions, but all of the solid lines here on this schema are safe. Okay. All right, so let's take a look on that. So right here we have a byte b equals, let's say 5, and you can declare in right here a short s and store the byte. There is no problem. We can also declare an int and receive the short. There is no problem. And the long L receiving the I. So far, so good. But if we try to do I equals receiving, let us say, the L, so maybe these imply on data loss. So we have a compiler error, okay? But since we assigned L from I, we know that it is possible to convert back. So the information right here, it is 5, the original information, okay? So if we print all of those, right here, South B, South S, South I and then south L, we should see the number 5 4 times. Okay, that's it. So 5, we know it can fit inside of a int, of an int, all right? So the way to do here, as we are sure about the data it is inside of the variable L, is to inform that to the compiler. And how can we do this? Using the cast operator. So we put the data type inside of parentheses right before the variable. And here we are saying to the compiler, represent or deal with the variable L as it was an int, not anymore a long, but like it was an int. And again, right here, it is totally fine. You can see the result right here. So 5 times the number 5. So all of the prints worked well. All right. So we can wide our type conversions as we did in the beginning. So right here, byte A to 5 and so on. So we are widening, we are increasing from byte to short to long to int and to long. Okay. And we can also narrow. We can narrowing type conversions. So we can put like this and a long 1L. We know that 1, it can fit inside of an int. So we use the typecast operator. Okay, so now we are representing a long data as it was an int. Okay, so casting, yes, it is one way to convert types, but not just actually converting, but representing like it was. Okay, so in a rough mode, yes, you can say that the casting it is a way of conversion. Okay, to convert data types. Okay, so now we know how to how to widening type conversions and also how to narrowing type conversions. Just use the uh, the typecast operator if it is possible to convert. Okay, so you are maybe thinking that could I put like a string text 5? Could I do like this? So a text equals int text. So in this case right here, it is not possible. Okay, because there is no directly representation from text from string to int. In the same way, we cannot do like Boolean. Uh, Let me put right here in another line. So Boolean, it cannot be so Boolean like false, and then right here like this. We cannot do this because there is no relation between Boolean and int. So all of the types allowed are based on this schema right here. So it is assured that you can convert from byte to short, from short to int. And you can do in the same way the back way using the typecast operator. So from long, you can try to cast to narrowing from long to int, and also from int to char, okay? And of course, from double to int, you can try to convert using the typecast operator, okay? But there is no assurance of that. You can try to do that, okay? But all the narrowing operations are not safe. All of the widening operations, yes, they are safe because you are going from the small to the bigger, but the narrowing operations are not safe.